All right, hello everyone. So for those of you who have taken physics, we are finally at the point where we're going to learn law of sines and law of cosines. For those of you who haven't taken physics before, all right, this will be something new for you guys. So we'll try to, cover every basis as possible. Now, the only thing that I am a little bit concerned with in terms of those of you who've taken physics is that you have not covered what we know as the ambiguous case, because in physics you're doing a lot of applied problems, so all the problems are going to have a solution. Now we are going to cover some triangle cases where you're just not going to have a particular solution, so that may be something new for you guys. Again, I'm not sure what exactly you cover in physics in terms of law of sine, law of cosine. I know you do a lot of applications with bearings and such, but we're going to kind of look at all possible cases mathematically, all right? Okay, so the law of sines is basically the ratio here, in a particular triangle. It can be any triangle that we use these for, but we typically use them for the oblique cases, which just means that there is no right triangle in the figure. Okay, so we can use them for acute triangles, and we can use them for obtuse triangles. All right, so the idea here is you have these three sets of ratios where you have the side over the sine of the angle. Now, I just want you guys to understand that they're labeling A as a particular angle, and small a represents the side opposite of that angle. Right, and that applies for all of them, right? So B, capital B is the angle, lowercase b is the side, same thing with C. Okay, so you're just doing the ratio of the side to the angle opposite of it. Okay, now notice that you can also write this as this ratio instead if you wanted to. Okay, right, it doesn't matter which way you write it, because again, we know based on the properties of ratios that that's also an equivalent form of it. All right, so I'm going to go split screen here for most of the time because you do have to do a lot of calculator work, and I'd rather you guys see the calculator. So it might give me less space to write, but we'll see what happens. We'll adjust if we need to. Okay. All right. So first example here. Okay, so they provide us with a figure nicely enough. Okay, it says for the triangle in the figure 6.2, we were given two angles and one side. We were given angle C, angle B, and we were given lowercase b. They want to find the remaining angles and sides. Okay, so now I think the easiest approach here is to first find the third angle, okay, because we already have two of them, right? So to do that, what we're going to do is we're going to take angle A is going to be equal to 180 minus the angle C, so 102.3 and minus 28.7. All right, so let's do that quickly. 180 minus 102.3 minus 28.7. So I get 49. So angle A is equal to 49. Okay, so now we move on. Now we need to work with sides. So my hint to everyone usually is identify in the original problem which two of the corresponding sides were given, right? So we were given angle B and little b, which represents the side. So we're going to use that ratio for everything because that'll probably give us our most accurate answer. Because in some cases, when you find other pieces, you may round, which throws your answer off a little bit. Okay. All right, and then pay close attention to our significant digits here. It looks like our significant digits here is the 10th place, so all our answers should be in 10th place when we find them. Okay, so let's start with 27.4 over the sine of 28.7. That's going to be equal to, now again, this one doesn't matter. You just have to select which of the two you're going to want to work with. So let's start with C. So lowercase c over the sine of 102.3. Okay, that's going to be the first one we're going to want to solve. All right, so now algebraically, you guys know how to solve this, right? We cross multiply. That's nothing new, right? So basically what we're going to have here, and I'm just going to do it in one step, we're going to have 27.4 times the sine of 102.3. Figure out what that's equal to, okay? And we're going to take that answer and we're going to divide that by the sine of 28.7. Okay, and we get 55.7. So C is McGarrow instead of the approximation. Okay, all right. So now we need to do the other ratio, okay? And the next ratio is with the angle that we found of A. So again, we want to use the original setup. So 27.4 sine of 28.7, okay? And then that's going to be equal to, we don't know A, okay? But we do know angle A, and angle A is 49. Okay, so again, we'll cross multiply here and let's figure out what A is approximately. Okay, so we have cross multiply 27.4 times the sine of 49. Okay, that's going to give us that answer. We're going to take that answer and we're going to divide that by the sine of 28.7. Okay, and we get approximately 43. Okay, 0.1, because we can round that up to the nearest tenth, and the nearest tenth is going to go up because you have to look at the following decimal point. Okay, all right, so there you go. That's pretty much how we go about it. That's using law of sines. Now, using law of sines is very, very easy when they give us two angles, okay? When they provide us with the two angles already, finding the third angle is very simple, and then everything else is just very, very easy to obtain, okay? It gets a little confusing later on when we're only given one angle, okay? So we have another example here, okay, that has two angles, I believe. And this one's kind of more of an application problem, right? And they gave us the image. So a pole tilts toward the sun at an 8-degree angle from the vertical. So the vertical being the point which is perpendicular to the ground. All right, so notice how it's leaning 8 degrees in one direction. It casts a 22-foot shadow, which is the ground, on the ground there, the C value. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. Okay, so they already provided that in the figure. All right, so they wanted to tell us how tall is the pole. So basically what we're looking for is we are looking for A, okay? We are looking for A, right? So we're definitely going to have to use the ratio of A. All right, now which ratio did they provide us with if we have any, right? So, well, we have angle A, but we don't have side A. We have angle B, but we don't have side B. We have side C, but we don't have angle C. So this one, we're going to have to figure out that third angle first, okay? So let's do that first. So we have 180 degrees minus the 43 for A, minus the 98 for B is going to give us the angle for C. So 180 minus 43 minus 98 gives me 39. So 39 is going to be what my angle C is going to be equal to. Okay, so now that I have that, I have a ratio that we kind of can use. We can use that 22 for the side of C over the sine of angle C, which we just found to be was 39, is going to be equal to a little a, which is the height of the pole. That's what we want, the length of the pole, which is what we want to find, and over the sine of 43. Okay, so this one we don't have to solve the whole triangle because they're telling us specifically to find A. Now that we can do that, we just go ahead and cross multiply. Let's figure out what A is going to be equal to. We cross multiply, we're going to get 22 times the sine of 43. We're going to get that as an answer. We're going to take that answer and we are going to divide that by the sine of 39. Okay, and I get 23.8. All right, so it's approximately going to be that tall. All right. So again, there's a nice little application problem for you. So something using the law of sines again. But again, it's nice and simple because again, they provide us with two angles. All right, so it's always easy when they provide you with the two angles. Okay, so the ambiguous case is when you have side-side angle. You're given two sides and you're given one angle. Okay, now I'm going to explain why this is the ambiguous case. Now this chart here is good for you guys to know and to understand. I'm just going to try to put this chart in kind of more simpler terms, right? So the idea here is, let's say we have an acute angle. I'm going to try to draw this as best as I can, right? And let's say we were given these two sides and this angle. Now, well, the third side has many different options, right? So what could happen here is I can draw a third side and it could be short of connecting of a triangle. If it's short in terms of connecting for a triangle, then that's going to case where we're going to have none, right? Because when we do the mathematics, if we get a shorter angle, then it's not going to satisfy, you know, creating a triangle to begin with, right? Okay. Now, And what I mean by that is like this side here is technically not provided. So let's look at it in terms of a dashed line instead. Because the angle that's given has to be measured from kind of the zero line, which is here. So it's measured from here and it goes positively, so you have your angle here. Then you're given this side and you're given this side. Now notice that there's no possible way that that's going to connect to keep that angle where it is because this segment here is just too short to reach this line. So it's never going to intersect. So basically what's going to happen is you're not going to have a triangle formed from that case. Okay. Now this one here, okay, this one is an interesting case because this one is a case where you're actually given the kind of like the almost perfect length where the height of the triangle is equal to the length of one of the sides, which kind of makes that just a right triangle, right? So we know in right triangles, when we solve right triangles using some trigonometry, we're always just going to get one solution for the right triangle, okay? So that's why that one is not necessarily too difficult to work with. All right, now here's one, and again, this is where A is large enough, okay, to create a triangle for us. The ones we have to kind of worry about are here because we have options of 2 and none. The 2 one is interesting because what actually happens, okay, is we have ourselves our angle, we have a side. Now this third side kind of may have the ability to kind of swing, in other words. So you can have the case where it intersects the triangle here, but then this can kind of rotate like a pendulum and intersect here. The question becomes is we don't know where exactly it's going to rotate, right? So it has the pendulum effect where this is going to rotate all the way over here. So it has 2 cases where that segment can intersect the same line. Okay, if that happens, then you actually have to solve both of those triangles because again, we don't know which one we're working with. This is why I say that it's a little different where in physics, because in physics, you're probably provided with information for one particular situation. But here we have the possibility that the triangle can be solved in 2 different cases. And mathematically, we need to cover all possible solutions. Even though in the application field, both solutions may not make sense, mathematically we always find the 2, okay? So that's where it's going to be a little different, okay? So we're going to try to cover as best as you can. Again, copy this chart. It's for good benefit. Now, where they're talking about the height, they're talking about the height is equal to the product of length B times the sine of A. And if you can compare, these are the conditions that have to occur for this case to occur, all right? So again, you have acute triangles on the left-hand side, obtuse triangles on the right-hand side, and it tells you with this chart exactly how many solutions you should be expecting. Now, what I'm going to try to do is I'm just going to try to create the process the same exact way so no one gets confused. And then you're just going to mathematically realize that some situations occur more than once, some situations are just going to give you one answer, some situations will give you none. All right, so we're just going to kind of go ahead and approach it the same way each and every time. Okay, now for the purpose of this section, I just want you guys, anytime, if they tell you to draw a triangle, notice how they're writing it in here. They're going angle A, angle B, angle C. Please follow that same pattern just so it's easier for you to kind of work it out. Okay, all right, so for this triangle, they give us that A is 22 inches, B is 12 inches, and angle A is 42. All right, so find the remaining sides and angles. So let's just go ahead and use the law of sines, law of cosines to find the remaining stuff, and then let's see if we get one solution for everything. Okay, so here we're going to go 22 over the sine of 42, because that is what ratio is actually provided to us. Sine of 42 is equal to, now it looks like we're going to have to find angle B first. So it's going to be 12 over the sine of B. All right, so really quickly what I'm going to do is I'm going to cross multiply. So we're going to get 12 times the sine of 42 over 22 is equal to the sine of B. Okay, so now remember, we're solving for B. B is an angle, so we're going to have to use the inverse of that eventually. But first, let's figure out what the left-hand side here is equal to. So, okay, so we have 12 times the sine of 42, close parentheses. You're going to get 8.029, blah, blah, blah. We're going to take that answer. We're going to divide that by 22. All right, so notice that we're going to get here about 0.3649 is equal to the sine B. Okay, now keep in mind, we solved trig equations already, that this value needs to be between 1 and -1, right? Sine does not pass those values. Sine is always between -1 and 1. So just make sure that that's the case. It is here, so now we can solve it. We're just going to take the sine inverse of that. Let me see where my sine inverse is. Here it is, sine inverse of the answer that we just received. And we get about 21.4. Okay, so 21.4 degrees is going to be the approximation B. All right, now remember, we are working in degrees. Make sure your calculator's in degrees. If you're using the TI-83, TI-84, any graphing calculator, just make sure of that. If you're using a regular scientific calculator, you'll be fine. Okay, all right, so there you go. You get 21.4. Okay, so now I know angle B is 21.4. I can quickly find angle C now because I can just subtract. So 180 minus 42 minus 21 minus 42 minus 21.4. Okay, so 180 minus 42 minus 21.4. That gives you 116.6. Okay, so angle C is 116.6. Now, here is how I want you guys to check and see if a second triangle is possible. We found this angle to be angle B, right? Now, remember, we just took the sine of this ratio. Now, what do we know about sines in quadrant 1 and quadrant 2? Sines in quadrant 1 and in quadrant 2 are positive. Okay, so that tells me that there is a possibility that a sine of the same ratio in the second quadrant is a possibility. So what is the reference angle for 21.4 in the second quadrant? To find the reference angle, we just subtract that from 180. It's just the supplement. So that's going to be 180 minus 21.4. We get 158.6. Now, with what's already given, which the 42, is 158.6 even possible to be in a triangle? That is going to be a no, right? 158.6 plus the 42. Oh my God, 42. Gives you 206, which is no way in form a triangle, right? 206 degrees is too large. So what that tells me is that the reference angle of 158.6 is not a possibility. So how many different triangles can I solve? I can only solve the one where we're going to use the 21.4, okay? So then you just solve that particular triangle only. All right, so again, the third angle here is 116. That's going to be angle C. We have angle B. The only thing now we need is little c. So we'll do 22 sine of 42 is equal to little c over the sine of 116.6. Okay, so then we go ahead and we do that process. So we have 22 times the sine of 116.6 divided by, we're going to take the answer, divide that by sine of 42. So I get the length of C is approximately 29.4. Okay, and then there you go. Okay, so you have little c, you have big B, and you have big C. All right, so again, this process here, finding the reference angle, is going to help us determine if there's one or two solutions. Okay, so that's where we kind of need to go ahead and approach. Okay, so there was only one solution here. Again, why was there one solution? If we go back to the chart, okay, we have a obtuse triangle page. So it's obtuse. Okay, so it's either going to be none or one. So you had to compare A and B for both of them. So if we go back, look at A is 22, B is 12. So which one's greater? A is greater. So that means that it's going to be a one solution case. All right. Let me erase all these circles because we'll probably reference this back again in a little bit. All right. So that's why exactly we have one solution. So mathematically, just work it out. The chart is just going to confirm your findings most likely. Okay. All right. Here, show that there is no triangle for which A equals 15, B equals 25, and A equals 85. All right. So let's just do the work. Remember, no figure. So how are we supposed to draw this again? All right, so you're going to label your angles starting with A here, B here, C here. Okay, so we're going to just draw a random triangle just to see exactly what they're kind of talking about here. All right, so A is 15, so that's going to be here. B is 25, we get that here. And then this is 85. So let's just do some algebra to go ahead and try to find the first location we're trying to get. It looks like we're just going to try to find... let me pick a different color. Angle B first. Okay, so if we use law of sines, we're going to go side over the angle. So sine of 85 is equal to, we have 25 over the sine of B, which we don't know. Okay, so again, we're going to get 25 times the sine of 85 over 15 is going to give me sine of B. So again, we need to figure out what that ratio is. Okay, so let's clear this out. We have 25 times the sine of 85. We're going to take that answer, we're going to divide that by 15. So I get 1.66 is equal to sine B. Okay. All right, so now let's try to find the inverse of this. So we're going to go ahead and click sine inverse of the previous answer we had, and I get undefined. Okay, now why is it undefined? Well, you should have noticed that this value here is too large. Okay, it's too large. Okay, it needs to be between this range. Okay, that's too big. It's undefined. There's no solution. Now, if we apply law of sines with the information we had and we got a no solution, what that tells me is that there is no possible triangle for this figure. Okay. Now, let's see why that's the case. So, if we go back to the chart, okay, we had an acute triangle, and it said that A was less than H. Remember, H is B times the sine of A. So, let's figure out what B times the sine of A is. So B is 25, and sine of A is the sine of 85. Okay, so what's 25 times the sine of 85? That's 24.9. Notice that, okay, the H value here is greater than the A value, okay? The H value is greater than the A value. So because that's the case, there's no possible triangle for the figure. Okay, so again, just rules that we're following based on the chart, but we did everything the same. So again, approach it as you're going to solve it. In the case that you get a possibility that does not exist, then you know that there's no possible triangle for the figure. Okay, all right, so next one. Okay, here, find two triangles for which A is equal to 12, B is equal to 31, and A is equal to 20.5. Now they're hinting at us that they're telling us that there's two triangles, right? We know that that's not always going to be the case. You're going to have cases where they're not even going to tell you any information. They're just going to say solve the triangle. And you're going to have to find both possible cases, okay? All right, so let's go ahead and kind of start this. So let's draw a possible triangle. Okay, so we have A is 12. Okay, so we know this is A, this is B, this is C. So little a is going to be over here. Little b is going to be 31, and this is going to be 20.5. Okay, so let's go ahead and solve. So again, we have 12 over the sine. Oh my God. This stylus is not my friend. All right, let's just say that that's sine 20.5 is equal to, so we're gonna go with 31 over the sine of b. All right, so I'm gonna need a lot more space on my paper here, so please algebraically do that correctly. I'm gonna go ahead and just find the solution. So we're gonna go sine 31 times the sine of 20.5. Okay, and that's gonna give me 10.85. I'm gonna get that answer, and I'm gonna divide that answer by 12. All right, so it looks like we have a reasonable number to find a sine angle, to take the inverse function of. So we're going to do sine inverse of the answer. Okay, and I'm going to get 64.78. Okay, so let's go with 64.8. Okay, so right now, looking at this, I know that I'm definitely going to be able to find a third angle with this 64.8 and the 20.5, right? Now, remember, sines are positive in both quadrant 1 and quadrant 2. So what I need to check is the reference angle for 64.8 in quadrant 2. So what's 180 minus 64.8? Well, 180 minus 64.8 is 115.2. Now the question becomes is, can I still make a triangle with 115.2 and the 20.5? This time the answer is yes. So what that tells me to do is I actually have to create a second triangle. Okay, I kind of drew that too low. Okay, so my first triangle here is going to have the same information as the second one, but now we're going to call these A1, B1, C1. These are going to be A2, C2, B2 because it's the second case, okay? So now, this angle B in the original, so this one here, is 64.8. In the second one, this angle is 115.2 because both of these angles can satisfy one of the two triangles, okay? So now let's find a third angle in each, okay? So what's 180 minus 20.5 minus 64.8? This is 94.7. Let's look at the other one. 180 minus 20.5 minus 115.2, 44.3. Notice you have two possible triangles that add up to 180 degrees based on the reference angle, okay? All right, so now all we have to do in each of these is find the side C, okay? So let's do C1 first. So if I'm doing C1 first, we're going to use the original, so 12 over the sine of 20.5 is equal to C sub 1 over sine of 94.7. The second equation we want to solve for the second triangle is going to be 12 over sine 20.5 equals C sub 2 over what is that? This sine of 44.3. Okay, all right, so again, calculator work. So we get 12 times the sine of 94.7 equals that amount. We take that answer and we're going to divide that by the sine of 20.5. So I get C1 is approximately 34.2. Let's look C2. So 12 times the sine of 44.3. We take the answer and we're dividing that by the sine of 20.5. So C1 there is approximately 23.9. All right, so there's the C values for each of the two triangles. This is C2, sorry. So C1, 34.2, C2, 23.9. Okay, and that was all created because we have two possible triangles here. Okay, so you have to solve both in that case, right? So again, this one is telling us that there's two cases, but again, you should always just naturally do this step. Find the reference angle for that second angle that you just found. Again, this only works when you have two sides at an angle. So, you know, find the second angle, check for the reference angle for that second angle, and if it's possible, then you got a second triangle. If it's not, then it's just a one case. All right, so let's move on to law of cosines, okay? All right, so law of cosines is kind of based on the same triangle, right? So we have A, B, C, little a, little c, little b. Okay, so there's three different cases here, and it all depends on which one you're working with. But the idea, okay, it doesn't matter which one you work with. You kind of work with all of them, but the idea is, let's say we want to use law of cosines to find this one here. So you're going to follow this one, and a good way of remembering the formula without memorizing it with the A and the B and all that stuff is just think of it as this way: is you're taking the square of the other two sides. Okay, so this side squared, A squared, is equal to the square of B and C, which are the other two sides, and then you're going to subtract 2 times BC, so 2 times the product of those two sides, times the cosine of the angle you're working with, which is here. Okay, so that's a way to kind of approach it, not too hard. It works the same way. If you think about it that way, it doesn't matter which one you're referencing, you're still going to get the same result. But either way, they're here for you. Just make sure they're in your notebook so you can kind of use them. All right, so now what the law of cosines does is the law of cosines helps us with other cases that weren't possible with the law of sines, okay? What it does is it finds us a piece of information that was missing, which then we can use law of sines to finish it, all right? So this is kind of here in the case that we can't use law of sines right away. We use law of cosines to find a missing piece, so then we can use law of sines, all right? So let's take a look at maybe 2 examples, and then we're kind of done for the day. All right, so find the 3 angles of the triangle. So they want us to find the 3 angles. We don't have any at this point in time, okay? All right, so that's why we can't use law of sines, because law of sines, you need at least an angle, right? We don't have any. All right, so how do we approach this? Well, you just pick one of the angles you want to find first. It doesn't matter which one, right? So let's say I want to find angle A first, okay? So that means what I need to do is that I need to use this formula. A squared equals B squared plus C squared minus 2BC times the cosine of A. The reason why I need to use this one is because this is the only formula from the previous page that has the angle A in it, okay? So we fill all the information out, okay, as best as we can. So we're going to have A squared, so that's going to be 8 squared. Oh my god, I really need a new stylus. 8 squared, and it doesn't fix it too. Okay, equals B squared, so we have 19 squared plus C squared, which is 14 squared, minus 2 times BC, so we have B, 19, C, 14, times the cosine of A. That's going to be the variable. Okay, so basically algebraically, right, you got to get all this to the other side. Okay, so let's start the process. I know 8 squared, that's a quick one, that's 64. Okay, let's find the sum of 19 squared and 14 squared. So that's 557. Okay, minus, let's find the product of 2 times 19 times 14. It's 532 cosine A. All right, so subtract 557 to the left-hand side. Negative 493 equals negative 532 cosine A. Divide both sides by the negative 532, so we're going to divide this by take the answer, and we're going to divide that by negative 532. So 0.927. It's approximation of cosine A. So we take the cosine inverse of that ratio. So the angle A is approximately 22.1 degrees, okay? All right, so that's how you approach using the law of cosines in this example. Now that you have A, you can law of sines the rest of it, right? So we don't need to do anything else in terms of law of cosine. So law of sine it, if we're going to law of sines here, it's going to be 8 over the sine of 22.1, and that's going to be equal to, you pick one of the two sides, it doesn't matter, let's go with 14 over the sine of C. Okay, so we're going to have 14 sine 22.1 over 8 equals sine of C. Let's figure out what that ratio is. 14 times the sine of 22.1. And that's going to give me this value. We're going to take that answer and divide that by 8. So 0.65. Take the inverse of that. Sine inverse of that answer. And we get 41.2. Okay, so now the third one, you're just going to take 180, subtract angle A and angle C. So 41.2, 22.1, and let's see what we get. We get 180 minus 41.2 minus 22.1, and we get 116.7. Okay, there you go. Okay, so you have the three angles. This is angle B. All right, and then again, make sure you're not breaking any rules of geometry, right? The largest side, which is B, should be the largest angle. The smallest side, which is A, should have the smallest angle, so on and so forth. Like that all still applies, right? Don't forget about those nice little things we learned in geometry. All right, and the last one here is let's find the remaining sides and angles of the triangle, okay? Now here's a case where they give us an angle, but we can't use law of sines because we don't have a case where we have an angle and a side correspondence. See, we're missing A there, okay? And then these two sides are missing both of those angles. So we can't use law of sines yet, all right? But we can kind of find one of them to help us do that, right? So I think it's best if we just find A. So A squared is going to be equal to, that 2 does not want to come out when I write this formula. Look at that. Yep, okay. A2, there we go, equals B squared plus C squared minus 2BC times the cosine of A. Okay, so we're going to be solving for A. So A squared equals, we have 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115. So A squared equals 225 plus 100 minus 300, sorry. Cosine of 115. Okay, so I'm not going to cosine of 115 just yet because I want to figure out what all this is equal to here. We're going to find that. All right, so we're going to get 225 plus 100 minus 300 times the cosine of 115. So we get 451.79. Well, let's write that as 785, and then we're going to take the square root of that. So we're going to take the square root of our answer here, and we get 21.3. All right, so that's going to be length of A. Again, now notice that since angle A is definitely the largest angle in the triangle, then side A should be the largest side, which is true. All right, so 21.3 centimeters is going to be the length there. Okay, and then let's go ahead and find the other two angles. To find the other two angles, we set up law of sines again, and then we are done. Okay, so doesn't matter. Let's pick C. So we have 21.3 over the sine of 115, and that's going to be equal to little c over, little c is actually provided. So 10 over sine c. So 10 sine 115 over 21.3 is equal to sine c. Do the calculator work and we should be good to go. So 10 sine 115, close that, get that answer, take that answer, divide that by 21.3. We get this ratio, which is good for sine. take the sine inverse of that. We're going to get 0.425. Oh, so, well, actually, I don't know why I'm doing that. It should just be the answer. And we get 25. So C is approximately 25.2 degrees. So now that we have C, okay, we just need to find angle B. Angle B is going to be equal to 180 minus 115 minus 25.2. So B is equal to 180 minus 115 minus 25.2, 39.8. There you go. There's using law of cosines. All right, so again, law of cosines is just rarely used. It's only used in the case that you don't have enough information for law of sines. Law of sines is the one that you're always going to be using in every single problem, okay? Law of cosines is only there if you can't use law of sines. If you physically see that, or if you see that you can't use law of sines, that's when you know you have to use law of cosines first. Then you, again, use law of cosines for the rest of it. All right, thanks for watching. Hopefully this worked out. Sorry for any of my miscues in terms of writing and using this technology. I'm getting better at it, but again, it's a day-by-day effort. I haven't mastered it yet. Hopefully everyone's okay. I'm wishing you guys all the best. You know, it sucks to be like this for this long. You know, hopefully we get to enjoy whatever we have left. All right, enjoy this because after this section, we are going to dive into some calculus, which I'm very, very excited for. So we'll see how that goes in terms of remote learning. But, you know, it shouldn't be too bad. You guys have been very good all year, so I'm looking forward to that. All right, so again, thanks for watching.